Welcome, everyone. This is it's a wonderful opportunity in front of us this morning and for the next day and a half. I'm really excited about this. My name's Chris Weiss, and on behalf of Director Linda Birnbaum of the National Institute for Environmental Health Sciences, I want to welcome you here to this meeting on applying 21st century toxicology to green chemistry and material design. We're going to have a very interesting day and a half here. I don't want to take very much time here, but just for those of you who are not familiar with the Standing Committee on the National Academy of Sciences Standing Committee on Emerging Issues in Health Science, this meeting is hosted by the Standing Committee. The Standing Committee has had a number of very interesting workshops over the years. It's been operational for about 2 years now, right, Bill? A little bit more than 2 years. We hope to continue that for several more years in this uncertain budget time. But they are the hosts of this meeting, and NIEHS is very proud and happy to be a funding source for them, and hope to continue this for some time. I want to recognize just a few people here who have helped put this together. Dr. Bill Farland is the chairperson of the Standing Committee. Marilee Shelton Davenport, Keegan Sawyer, and Aisha Saeda are the folks who have really done a lot of the background work on this meeting. I want to recognize them. You'll see them buzzing about, helping make sure everything falls into place. This particular workshop, and I would invite you, by the way, to go back and, if you're interested in the Standing Committee, look at some of the workshops that they have hosted. There are some very interesting and somewhat controversial emerging issues that you can review on the website. You can also see what's coming up in the future. And I invite anyone who's interested to join us for any future workshops that we have. This particular workshop is a little bit different and interesting to me because it is also co-hosted by the White House Office of Science and Technology Policy, the Committee on Environment and Natural Resources. We're very happy to have Dr. Paul Anastas here with us. Paul is a co-chair of that White House committee, and I am honored to be a co-chair of one of the subcommittees, the Subcommittee on Toxics and Risk for the CENRS. And we are co-hosting this. A lot of the discussions that you'll hear over the next day and a half are sort of conceptualized by the Toxics and Risk Subcommittee. And I'm honored to co-chair that subcommittee with Dr. Hal Zenik, who's here today. Hal. Patrick Mason. I'm not sure if Patrick's able to make it. Patrick's with the Department of Defense. Dr. Bruce Roden is our OSTP liaison. Bruce is here. You'll see him around here today. And I want to just recognize our Executive Secretary, Bob Boyd. So those are the folks that are hosting this meeting today. And if you have any questions or have a chance, hopefully during the breaks you'll be able to mingle with some of these folks, and really looking forward to a very productive day and a half. I would say that the Toxics and Risk Subcommittee, the CENRS, the mission of the CENRS is really to identify emerging issues in environmental science and stimulate the research having to do with those issues. And it's my hope today, and I think I share this with my co-chairs of the Toxics and Risk Subcommittee, it's my hope that we can really today sort of dream a little bit about a future where green chemistry really moves into place, it moves into the marketplace, to the extent that is possible, sort of short circuits the need for regulation and allows us to move forward into a planet where we're thinking ahead a little bit about chemistry and the effects of chemicals and materials that we use, as opposed to responding to various problems that arise due to those chemicals. So that's my hope, and I think that's a hope that's shared by everyone in this room. I dare everyone to dream a little bit, take some risks, step out a little bit, and if we're lucky, maybe we can identify some research proposals, some issues that can be addressed and would really further this cause. So with that, I just want to turn it over to Richard Dennison. Richard's going to fill you in on a little bit of the logistics of the meeting and some of the ground rules and that sort of thing. Richard, thank you very much.
Great, thank you. Good morning, everybody. It's great to see you all here. This is an exciting topic, and I think we've got a great lineup of speakers for the next day and a half. I would like to just spend a couple of minutes giving you a little bit of an orientation to the work that went into putting this together and some of the objectives. You see on the slide before you the three main objectives that the committee identified in putting this together. We're trying to move in a direction of getting different disciplines to come up out of their silos and look around at each other and start thinking about ways of integrating across different ways of thinking about chemicals and chemical safety, and that's one of the purposes of the meeting today. We are going to be in one of the sessions getting into a little more detail in terms of some of the types of methods that are evolving, and we're asking speakers both to give an overview of those methods, some of their strengths and the challenges that remain, and then also be sort of bridging to how they might be applied in the context of greener chemical and process design. And then thirdly, we're going to be always thinking about how we place the issue of green chemistry and new toxicology into the broader context. And our opening speaker today is going to be addressing that quite directly in just a few minutes. This is the planning group that put together the workshop. We were led in this effort by Lauren Zeiss from Cal EPA, who chaired the planning group. And you see a number of members of the committee with asterisks after their names there, as well as a number of the liaisons from other agencies with whom we worked to put this together. It was pretty intense getting all of the speakers lined up and so forth, and all of these folks really did a lot of work in that planning exercise. A few themes I just want to touch on very briefly. We are really trying to bridge a gap that I think many of us recognize in this area between chemistry and toxicology, where the consideration of how to design chemicals and what properties to imbue them with has often been divorced from the considerations about the toxicity of that, and that those really are separate exercises often. We're trying to bridge them, bring them together, think about how they could be better integrated from the very beginning of the chemical design process. We want to be looking at some ways in which this exciting new science that's beginning to emerge, giving us a much better understanding of how chemicals interact with our biology, and new methods that are being developed both to explore those interactions, but also to be able to more effectively and efficiently test chemicals. How those emerging methods, which still have quite a ways to go in terms of certain types of uses of them, how they might be applied in the near term to some areas that might be potentially less controversial, less difficult to deal with some of the uncertainties that are still remaining with those methods as they evolve and emerge. So we're looking for some practical examples of ways in which we could start to use these methods sooner rather than later. As was mentioned by Chris at the very beginning, one of the interests, particularly in the OSTP and in the committee that Chris mentioned, is this idea of shifting the paradigm, beginning to move away from responding and thinking about toxicity of chemicals after the fact really integrating it up front, right in the initial conceptualization and design of chemicals and chemical processes. And finally, we're looking for ways in which we might integrate the kinds of information that emerging methods provide into either existing frameworks that would need to be adapted, or how we may need to develop new frameworks for thinking about how we use this information to compare across chemical alternatives, and to to integrate these into a more predictive and preventive paradigm. 3 sessions today. We're going to start broad and then dive deep and then come back up for a sort of broad discussion at the end. Session 1 will really give us some groundwork and kind of a vision for what we're thinking about here, and we've got some great speakers I'll introduce in just a minute. We're going to get into the details in Session 2. We have a series of speakers that will be walking us through a number of categories of emerging methods in this exciting field. They're experts in their field, and they're going to be able to give us a great overview of what these new methods and technologies are allowing today. And then finally, we're going to come back up and really look at how we can start applying these, what are the major needs for advancing this field, and really being able to utilize these methods in informing greener chemical design. Okay. We're also leaving lots of time for discussion, so one of the nice things about these workshops, in my experience of them, is the best part is often the interaction between the speakers, panelists, and all of you in the audience. So we're going to try to build in quite a bit of time for that. All right. So let me now transition into our first panel. And I have before we do that, I have to give you a few of those ground rules that Chris mentioned. This committee is not a typical National Research Council committee. It does not work by consensus. It doesn't produce reports. So the opinions that you're going to be hearing today and the perspectives are those of the speakers and the panelists, and not the National Research Council. There will be a summary of this put together in the form of a newsletter. You saw a number of those out on the desk if you looked from earlier workshops. So we're going to try to capture the highlights in that form. The meeting is being webcast. So when you are asking questions or making comments, we'd ask that you state your name and affiliation. And finally, could everybody make sure their cell phones are off so we don't have any undue interruptions? Okay, now let me make that transition. I'm going to introduce our first speaker, who's got a very busy morning ahead of him so that he can get started. It's my distinct pleasure to welcome Paul Anastas to kick us off this morning. Paul, as probably all of you know, is the Assistant Administrator for the Office of Research and Development at EPA. He is the Science Advisor to that agency. Paul has a history and a work experience that is perfect for this workshop. In his current capacity, he oversees the parts of the agency that are trying to advance the field of green chemistry, where his roots lay. He's also overseeing the part of the agency that's trying to advance 21st century toxicology. And those are basically under the same roof, Paul's roof at EPA, so he's in a perfect position to be able to help bring those things together and to give us a vision and a sense of where we are and where we want to be going. Prior to joining EPA, Paul was the director of the Center for Green Chemistry and Green Engineering at Yale University. He was, prior to that, the founding director of the Green Chemistry Institute, which was established by the American Chemical Society. He's trained as a synthetic organic chemist, so he knows what he's talking about when it comes to designing chemicals. He's published widely on this. He's written 10 books. 2 of them I'll note just very briefly. Benign by Design, which I think the title speaks for itself, And his work that really led to Paul and his colleague John Warner being called, in just about every time I've ever heard him introduced, the fathers of green chemistry. That work was called Green Chemistry Theory and Practice. So, Paul, please kick us off. Thank you.